Hello and welcome to section 1.1 on angles and their measure. This is the first section in the trig segment of our pre-calculus course. Our first essential idea is to define angles in standard position. So we want to do that in order to be able to say that our angles are inputs to functions where they can take on values between negative infinity and positive infinity. Up until now, your knowledge from your geometry course is that an angle is inside of a polygon or even outside of a polygon, but that's how we've thought of angles up until now. Now we're going to expand on that idea a little bit. All right, so if I look at this drawing here, I'm going to put my angles system on the standard XY coordinate system, where this is your standard XY setup, where you've got Q1, Q2, Q3, and Q4 the same way we normally do. So an angle has an initial side which lies on the positive x-axis. And then our center of rotation is the origin. And then we have the terminal side, which you can think of as a spinner, like in a game, where you're rotating either direction, this way or this way, as many times as you want. That allows us to grow our angles bigger and bigger and bigger, or smaller and smaller and smaller, or more negative. All right? So we have a sign convention, positive and negative. So over in this picture here, I'm talking about a negative angle. So negative direction is this direction here, which is clockwise. And over in this other picture here, positive rotation is counterclockwise. So your angle has a positive sign or a negative sign. And then we usually use Greek letters like alpha, beta, theta to represent our angles in this system. So in this picture here, our angle is represented by the Greek letter theta. So let's put some degree measures on here. So if I'm going in the positive direction, this would be 0 degrees, then 90 degrees, then 180 degrees, then 270 degrees, and one full revolution would bring you back to 360 degrees, which is in the same position as 0 degrees. So if I were going in the other direction, so if I were going in the negative direction, this would be negative 90, negative 180, negative 270, and let's see, this is 0 to start with, and negative 360 degrees, which is one full revolution in the negative direction. So as you can see, positions on this system, in this system, can take on many names and still lie on the same terminal side. And we'll get into that in a little bit. So let's practice this idea for a minute and look at 4 examples. So the first one says sketch negative 240 degrees. So that means I want to rotate in the negative direction. This would be your negative direction. So I'm going to write my initial side on the positive x-axis, and I'm going to rotate negative 240 degrees, which is 240 degrees in the negative direction. So I would go negative, starting here, I'd go negative 90, negative 180, and then 60 more degrees, and I'd wind up here. So this would be my terminal side. Right here, this would be negative 240 degrees. And my arrow indicator right here, this indicates that I swept through in the negative direction by this amount. Right, now let's look at this one here. 100 degrees, this one's positive. So I'm going to rotate in the positive direction. Here's my initial side, and I want to rotate 100 degrees. So I'm going to go 90 and then 10 degrees more. So I'm going to wind up right here. This arrowhead indicating I swept through in the positive direction. And this would be 100 degrees. All right, now we've got negative 50 degrees. So if I'm going in the negative direction again, I'm going this way. So I'm not going to go full 90 degrees. So here's my initial side. So I'm going to go past 45 degrees a little bit to about there. And that would be negative 50 degrees. Okay, one more, 20 degrees. So I'm in my, here's my initial side. I'm going positive again. This time I'm going 20 degrees from my initial side, which is just a small rotation here. And I wind up here, 20 degrees. Okay, so that's how you draw an angle in our standard coordinate system. Now we need to talk about radians. So radians are another way to talk about the amount of rotation that you have. So degrees and radians can both be used to identify the amount of rotation you have from your initial side to your terminal side. So what a radian is a piece of your circle on the outside of your circle here. So you can think about it to visualize what we're talking about is that here is your radius of length r. If you think about it as being a piece of string so that we can bend it, 1 radian is that piece of string of length r laid on the outside of your circle. So we have some prior knowledge about radians without maybe even realizing it. We know that the circumference of a circle is 2 pi r. So a long time ago, mathematicians discovered that there were 2 pi r's along the outside of any circle. So we know that 2 pi would be approximately 6.28 because pi is approximately 3.14. So 6.28 times r gives you the distance around your circle. So what that tells us, if I look at my picture here, is that I can count 1, 2, 3, 4, 5, 6, and then 0.28 would be roughly a little bit less than a third of a radius more. That's this number, 6.28 times this value r, which is the radius of your circle. So that gives you this length around the circle. So in essence, a radian is a count of the number of these that you have around your circle. And that's a way to give a value of an angle. So what I mean by that is if you go one full trip around the circle, that's 360 degrees, that would have been 2 pi radians. So that's an equivalency. 2 pi radians is equal to 360 degrees. So if I wanted to find out how many degrees this was here to sweep through 1 radian, I could take 360 degrees and divide it by the number of these pieces that I have, which we know is 6.28, or more accurately 2 pi. So if I punch that into my calculator, 360 divided by 2 pi, I get that 1 radian is approximately equal to 57.3 degrees. All right, so that gives you a feel for how many degrees you would swipe through if you had this distance r along the outside of your circle. All right, so this here is 57.3 degrees, which makes a little bit of sense because we know 45 degrees would be about here, so it's more than 45 degrees, less than 90 degrees, closer to 60 degrees. Okay, so 1 radian is equivalent to 57.3 degrees. So we're going to need to be able to convert between degrees and radians in trig. So we learn to do that right away. So we already established that our equivalency between degrees and radians is 2 pi radians is equal to 360 degrees. So I can form a fraction that's equivalent to 1 by either writing it like this or like this. So we call these conversion factors, and you've seen some of that going on in chemistry. When you want to convert between units, you have to come up with a fraction that gives you a 1 so that you can multiply by what you have originally without changing the magnitude of it. You're just changing the units. Okay, if I reduce 2 pi over 360, I get pi over 180. If I reduce 360 over 2 pi, I get 180 over pi. So if I want to convert from degrees to radians, I would want my degrees to cancel, and I'd be left with my radians. If I want to convert from radians to degrees, I would want my radians to cancel. So that's how you know whether you're going to have the fraction oriented this way or oriented this way. And we're going to work on some of this next. So this example says convert the given angle from degrees to radians. So let's start with 210 degrees. And I have to figure out which way I want to write my conversion factor such that I end up with radians on the other side. So I want my degrees to cancel, so that means I'm going to put my 180 on the bottom and my pi on the top, such that when I multiply, my degrees are going to cancel out and I'll be left with radians. All right, so most of the time, this is the convention, you're not going to have radians written right here, all right? Nor are you likely to see it here. Radians are considered to be a unitless dimension in most parts, in most situations. All right, so now I've got 210 pi divided by 180, and I can reduce that. Cross out my 0, which is the same thing as dividing by 10 in the numerator and the denominator. Let's see, and then I can divide by 3 here, 3 here. And I would generally write this as, I'm going to erase that, I would write that as 7 pi over 6, leaving the pi in the answer and not writing the units. Next, let's take 30 degrees and convert it to radians. So my conversion factor would be oriented this way so that I could cancel out the degrees, and I'll be left with radians. So cancel the degrees. So I've got 30 pi over 180, and I'm going to reduce that. Divide by 10, divide by 3, and then I'm going to write my answer in terms of radians. I mean in terms of pi, so that's 1 pi on the top, so we'll just say pi, and then 6 on the bottom. Pi over 6. So 30 degrees is equivalent to pi over 6 radians. So now we're going to convert negative 300 degrees into radians in the same way. We want to cancel the degrees, which tells me that a 180 belongs in the bottom. So canceling your degrees and writing your answer in terms of pi. I have negative still, so this is still a negative rotating angle. Negative 300 pi over 180, which I'm going to reduce. Divide by 10. Let's see, divide by 6. So I'm going to write my answer in terms of pi, negative 5 pi over 3. So we've converted from degrees to radians. Now we're going to go in the other direction. So we're starting with And the first one, pi over 4 in terms of radians, so I'm not going to write radians. I want to end up with degrees, so that means I'm going to flip my conversion factor upside down relative to how we did it the other way, and I'm going to cancel. So the pi's are going to cancel. I'll be left with 180 degrees divided by 4, which I would reduce. 2 goes into there, 2 goes into there. So I reduced it, and I'm left with degrees, which I do write my symbol like this. So this is 45 degrees. Next, we've got negative 5 pi over 6 radians. I'm not writing radians. My conversion factor would be oriented this way so that my pi's are going to cancel, and I'll be left with degrees. So now I'm going to cancel the pi's. So I've got negative 5 times 180. Negative 5 times 180, which I'm going to leave like that for a minute, divided by 6. Now I'm going to reduce that. 6 goes into 6 once, and 30. So I've got negative 5 times 30, so that's negative 150 degrees. So you want to make sure you don't drop your negative. Your negative will stay. That's just the direction that we rotated to get this angle. All right, the next one, it doesn't have a pi in it. The pi is included in this number. You might think of it that way. So this is just 1.5 radians. And I want the degrees to wind up on top. So I'm just going to say this is 1.5 times 180. And then we're just going to type this into the calculator, divide by pi, and we'll get a certain decimal number of degrees. And I got 85.94 degrees. Next idea here is the degrees, minutes, seconds units, which are a more refined way of writing your degrees. So angles can be broken down into minutes and seconds, much like hours can be. So we call that the DMS system. It's a base 60 system, like hours, minutes, and seconds are a base 60 system. Meaning there's 60 seconds in a minute and 60 minutes in 1 hour. So high precision angle measuring devices use DMS for accuracy, such as land surveyors and GPS. So we're going to learn how to convert between DMS and decimal form for angle measurements. So in this example here, we're going to convert degrees to DMS. So what that means is we want to go to this setup here. 233, that would be your degrees, plus some number of minutes, plus some number of seconds. And we use this symbol for minutes and this symbol for seconds. All right, so the first thing we want to do, we've already got the 233 degree part here, that whole number part here. This part over here, 0.378, we're going to break down into minutes and seconds. All right, so we take this 0.378 and we say that's equal to some number of minutes out of 60, some fraction of 60 minutes. So if I do cross multiplying, I can say x is equal to 0.378 times 60. So if I run that through the calculator, that gives me 22.68. All right, so now I take off that whole number part here, 22, and I put that here. All right, so that's 22 minutes. Now this decimal part here now, we have to break down into the second section, put in the next box. So we're going to say 0.68 is equal to y over 60 seconds. So 0.68 is some fraction of 60 seconds now. So if I do cross multiplying again, I can say y is equal to 0.68 times 60, which is equal to 40.8. All right, so then that part goes in this box here, and that's as refined as we want to get. So if I just write that out, we're going to say 233.378 degrees is equal to 33 degrees, 22 minutes, 40.8 seconds. And the convention is this is a whole number of degrees, a whole number of minutes, and whatever fraction of seconds you leave the decimal point part on that unless you're specified otherwise. So in this example, we're going to convert 279 degrees, 40 minutes, and 23 seconds to degrees in decimal form. All right, so you start out by saying you've got 279 degrees, that's this part, plus 40 minutes out of a total of 60 minutes in a degree, plus, that's this part, plus 23 seconds out of a total of 3,600 seconds in a degree. So the parallel here is like with hours. So if you have 1 hour, then you've got 60 minutes in 1 hour and 3,600 seconds in 1 hour. So this is all in degrees, in degrees, in degrees. So we can add these three things up, and we should have just plain degrees. So I'm going to go ahead and I'm going to punch that all into my calculator and get a decimal number. So I got 279.673. All right, so this is just plain degrees. All right, so it's a lot easier of a calculation going in that direction there. Now let's talk about coterminal angles, which is the idea I alluded to in the beginning of our discussion here about how you can name a certain terminal side in many ways. So if I look at this picture over here, here's my initial side on the positive x-axis, and here's my terminal side here. Okay, over here I say there are infinitely many angles with the same initial and terminal sides. Rotating in the positive direction counterclockwise or the negative direction clockwise by any number of full revolutions will take you to the same place on a circle. So they have to be full revolutions, of course, but you can get to that same terminal side by doing a number of things. So one full revolution, as we discussed, is 360 degrees or 2 pi radians. So looking at this picture here, if I start on my initial side and go this much, I land here. So this is this little bit. But I could also get there by going here and landing here. I can go that much, or I could go more revolutions, and I could land there. Or you can go in the other direction. You could go, let's just say you start here, you can wind up here, or you can go around multiple times and you can wind up here. You could keep going many more times and you can end up here as well. But each time I did that, I've gone multiples of full revolutions, either in the positive direction or the negative direction. So those are all going to wind you up in the same place, but your size of your angle is going to be different depending on how many revolutions you go. and your negative or positive could be different depending on the direction of rotation. So these are all called coterminal angles. That means they end on the same terminal side, but you've got different measures. Okay, so this example says, find an angle in the interval 0 to 2 pi that is coterminal with 31 pi over 8. Okay, so I want to check and see whether 31 pi over 8 is in between 0 and 2 pi. So it has to be somewhere between 0 and 2 pi. So I'm going to rewrite 2 pi in terms of eighths so I can examine this carefully. So that's 16 pi over 8. All right, so I can see that 31 pi over 8 is more than 16 pi over 8, so it's outside of that interval 0 to 2 pi. So I'm going to take off one revolution off of that, one full revolution. So one full revolution is 16 pi over 8, which is 2 pi. So 31 pi over 8 minus 16 pi over 8 is 15 pi over 8, which we can see is less than 16 pi over 8. So that is within that interval 0 to 2 pi. So we consider this a coterminal angle. Now let me show you what that means on a diagram. So if I've got my regular system here, where I'm going 0, let's do it in terms of eighths. So 0, which is the same thing as 16 pi over 8, we've determined is 2 pi. That would be one full revolution. So this would be half of a revolution, 8 pi over 8. And half of that would be 4 pi over 8. All right, so that means that every time I go 90 degrees, I've gone 4 eighths. So if I add 4 eighths to 8 eighths, that's 12 eighths. So I've got everything written now in terms of eighths so I can see this better. So my original problem said I had 31 pi over 8. All right, so let's count that and see where it takes us. All right, starting on my initial side, I'm going to rotate. So I'm going to go 8, and then 16 eighths, and then another 8 would be 24 eighths. Right, if I go all the way to 16 eighths again, that would be 32 eighths, and that would pass it. So I got to stop at 31 eighths. So this is 31 pi over 8. So it's 1/8 before I get to 16 pi over 8, which makes sense because this is 1/8 less than 16 pi over 8. All right, so that's my initial side here and my terminal side here. So what we're saying is that this also has the same terminal side. So if I wrote my angle 15 pi over 8, let's do it in green, I'll have this angle here, which winds up on the same terminal side, whereas the green one is the 15 pi over 8. These are considered coterminal angles because they have the same initial side and the same terminal side, but they've gone around the circle different amounts of rotations. Now let's try it in degrees. This time we're asked to find an angle within one revolution in degrees between 0 and 360 that's coterminal with a negative angle, negative 1138 degrees. Okay, clearly that's outside of the range 0 to 360. So in order to get from negative 1138 degrees, I'm going to have to add a positive revolution multiple times to get out of that range. So let's see how many times I have to do it. So I add 360 to that, and I get negative 778 degrees. Well, that's still not there, so I'm going to add 360 again to that. well, I got negative 418 degrees. So I'm still not in the range 0 to 360. So let's add another 360. This time I got negative 58 degrees. So I'm getting closer to being positive, but I'm going to have to do it again. So this time I'm in the range. I got 302 degrees. So 302 degrees has the same terminal side as negative 1,138 degrees, but it's within one revolution. So let's see what that looks like on a diagram. Okay, so there's our setup. So this angle is a negative angle, so that means I'm going in the negative direction on our coordinate system. This is your initial side. All right, so I've got to rotate a number of times to get to negative 1138. All right, so if I start out at 0 degrees, okay, so when you're writing one of these rotating angles, you can start close in here so you can fit all your rotations on there. So one full revolution gets to negative 360, and then I'd have to go another one to get to negative 720 because that's 2 times negative 360. And then if I go another 360 on top of negative 720, I get to negative 1080. So I just wrote those numbers down here so we could see them. So I'm already up to negative 1080. I need to go more. So that's negative 58, another 58 degrees in the negative direction. So that's another roughly negative 58 degrees. So that got me to negative 1138 degrees. Okay, so but we want it to be between 0 and 360, and we want it to be a positive angle, so that would be somewhere in this range, not all these windings here. Okay, so now if I look at how much of that angle would be 302 degrees, let's take a look at that and see whether it's on the same terminal side. So now let's go ahead and put on 302 degrees in this color. So that means I'm going in the positive direction 302 degrees. So positive direction 90, 180, 270, and so that's 58 degrees less than 360, so that would be to here. So that blue one represents my 302, and as you can see, I wind up on the same terminal side. Okay, so that's another illustration of coterminal angles. So the bottom line and the technique is you're going to either add or subtract multiples of either 360 or pi in order to get within the range that you're asked to get into here, whether in degrees or whether in the other problem we were asked to use radians. Just a correction I found in proofreading this video, you would add or subtract multiples of 2 pi, not pi, to wind up at coterminal angles. Okay, one more example like this. This one says find an angle in the interval, this time negative 360 to 0, which is coterminal with 955. So starting out with 955, I got to keep subtracting 360 degrees, one full revolution, until I get down in the negative range. So I'm going to do it one time, and that gets me to 595 degrees. That's still not enough, so I'm going to do it again. That gets me to 235 degrees, so I'm still not negative yet, but it looks like one more time should do it. So I'm going to take it down one more revolution. So I got it down to negative 125 degrees. All right, so that's within this interval here. negative 360 to 0. So I unwound that angle basically by 3 revolutions to get it down into the range that they asked for. So I drew a diagram here. So this pink angle, starting at 0 degrees, I'm going to have to wind around this many times to get all the way to 955 degrees. So that would be 360 and then 720 plus whatever amount this is, 235 degrees to get all the way to 955 degrees. All right, this angle here, this negative 125, we could represent that as starting here and going this piece of it here, this blue piece of it, and winding up here. So that angle there is negative 125 degrees, and as you can see, they have the same initial and the same terminal sides, but the value or the magnitude of the angle is different because the number of rotations and the direction of rotation. So that's the idea with coterminal angles. There are infinitely many names for a certain initial and terminal side on your diagram, depending on the number of rotations and the direction of rotation. So that finishes up part 1 of our discussion here. We have a couple more things, example problems I want to do, and I'm going to do that in a second video. So make sure you're taking good notes on these problems because this is how you will see them in your homework set.